Hi, this is Matt Morrison with Technically Speaking at Source Allies. Today, we are going to talk about Python, specifically a tool for Python, specifically UV. UV is an extremely fast Python package and project manager written in Rust. I am going to skip over the installation part. It's very easy. You can use pip to install it, but check out their website on astral.sh. You can get specific installation instructions there. I already have it set up and installed, so we're just going to go right from the next steps. Okay, so UV is a great tool. With my Python experience, I have primarily used pip and virtualenv to manage my Python environments, and UV offers an alternative to that. So let's walk through an example. So I'm going to create a brand new project using UV init, my project, and I'm going to cd into my project, and we'll see what we have here. So we can see it's created 3 files, and if I actually show hidden files, it's created a few other ones as well. Let's look at the pyproject.toml. So this is pretty standard for any modern Python project. The pyproject.toml supported by pretty much every modern Python tool, which we'll take a look at another example later. But this is basically metadata about your project: name of your project, description, version number, and dependencies. So dependencies are a big topic that we'll be talking about a lot today. So first, let's take a look at some dependencies. So if you watched my other Technically Speaking about mocking responsibly, we're going to do something kind of similar. We're not really going to get into the coding as much, but we'll use some of the same dependencies. So one that I like to use for calling APIs is requests. So I'm going to add requests, UV add requests. Okay, and you can see that it's updated my pyproject.toml file to add a request in there with a minimum version number. So that's great. If you remember from the Mocking Responsibly Technically Speaking videos, I also like to use PyTest and responses. And so PyTest to run my tests, responses specifically to mock out requests calls. So let's add those. These are a little bit different though, because these are not production runtime dependencies. These are just like development CI/CD dependencies. So I do want to keep those separate. So UV allows us to do this. So I can add responses, PyTest, dev, and that will create this dependency group with dev that kind of does the same thing, but it does keep those separate so that when I'm ready to package my application and deploy it someplace, I don't need to package my dev dependencies. I can just package the production dependencies. Okay, so far I've just done a command line tool to update a TOML file. Not super helpful, right? I could have just as easily manually edited the TOML file and we wouldn't be that much better off. Let's go ahead and create a test. So I'm going to create a test main.py, and we'll just create a failing test. Test fail, assert false. Okay, so we've got our failing test. So to use UV to run PyTest, I can just type UV run PyTest, and that will run my tests. And it's failing the way that we want it to fail if we have assert true, and it's passing. So let's leave it failing. So an interesting thing here that you may or may not have picked up on is I didn't ever do any additional steps to create an environment, kind of, going back to what I've primarily used, pip and virtual env, there are some additional steps. You've got to create a virtual env. You've got to activate the virtual env. You've got to do pip install. You've got to have a requirements.txt. There's more steps involved, but I didn't do any of those. All I did was the project init, add my dependencies, and then we're up and running. So let's take a look at our directory structure again. So you can see we have a virtual env already created for us. So virtual env in Python, if you're not familiar, is essentially a specific, think of it as like a specific isolated installation of Python and all of the dependencies for your project. So these are going to be local, not global to your whole machine. So it'll be just specific to this one project. So I could have 10 different Python projects on my machine. Each one has its own virtual env. Each one could be a different version of Python, have different versions of different dependencies, and not affect one another. So that's what a virtual env is. UV has already created this stuff for us, as well as some cache things. So let's delete some of this stuff and break it down a little bit. Some caches. We'll go ahead and delete that. So we've got our Git directory, our tests, our Python version, which let's take a look at that. So we have Python 3.13, which is fine. Okay, I think we got everything cleaned up. So now if I just try to run my tests again, I would expect it to fail because I just deleted our whole environment, right? It does fail, but it fails in the way that we wanted it to fail, right? So in theory, if we do that, it's passing. So again, I just deleted our whole environment and I just tried to run the tests again. And if we look, our environment exists again. So this is something that UV just does automatically. If you try to run something in UV, it will create your environment kind of for free automatically. So to kind of demonstrate some of the magic there, I'm going to walk through what I would have done to do the same thing with pip and virtual env. So again, I'm going to go ahead and delete these. It doesn't matter. We'll delete it anyway. Okay. So back to a clean slate. No virtual env. And I'm going to, first thing is create a virtual env. So I'm going to do Python mvenv.venv. So this is going to create a virtual env called .venv. And we will see that happen now. So now we should have our .venv again. There it is. And then I need to activate it. So I'm going to do bin activate. Okay. So now you can see on my prompt here, it's showing that we're in a virtual env. And then I can use pip to install my dependencies. And it's going to download, so I can see it got requests. Did it get my responses? Maybe it did, maybe it didn't. I don't know. We're not really using that yet, so we will see. Actually, we'll just do pip freeze and see what it did. I don't think it did. No, it doesn't seem like it did. Okay, so the pip install didn't install our dev dependencies, which is fine for this demonstration, but let's go ahead and run our PyTest, and we have our failing test. So kind of the same, right? We had some additional kind of manual steps to run there. And if we look at our project here, it's largely the same. We've got our virtual env. We've got some cache. We have this other stuff that pip created, which we can ignore. But we had to manually create, and I'm just going to clean this up. We had to manually create the virtual env, we had to manually activate it, we had to manually install things, whereas in UV, we just had to run the tests and all that happened for us. Another thing, and let's do this one more time. So create a virtual env, activate the virtual env. If I try to run PyTest, it actually does run, but that's because I actually have PyTest installed somewhere else. So that's just on my system. So if this project specifically requires a specific version of PyTest, it's not going to be using the right one. So that's not ideal. It's not isolated to my local environment. If I do Python, which Python this should be pointing at, yeah, so this is using my virtual env. So if I do, if I do Python m pytest, it says it's not installed. So this Python m pytest, this is a way that I can ensure that I'm just using the locally installed dependencies, not any global one, like if I just run pytest like this. So pytest isn't installed. Pip install dot. I think this should make it installed, but I also kind of think pip is not installing the dev dependency group. No, it's not. So there's some additional things that you kind of have to work through with using pip. I'm not as familiar with how pip interacts with the pyproject.toml. There may just be some flags or something that you can add to tell pip to install this other dependency group. That's not important. We're here to talk about UV. And with UV, you don't have to think about all that stuff. So one other thing, oops, let's back up. Okay. One other thing I wanted to point out about our pip environment here. So if I look at the Python version I have, it's 3.14.6. And if you remember, in our PyProject toml, we have that our project requires greater than or equal to 3.13, which, yeah, that's correct. But our Python version file is 3.13. So the Python version file should be the thing that determines the version of Python that our project is using, which pip is not going to manage that at all. If you want to manage the version of Python, you need to manually take care of that when you're creating your virtual env. So before pip even comes into the picture to install your dependencies, as you're creating your virtual env, you need to make sure that you say, create this virtual env using this version of Python. And then you need to have that version of Python available somehow on your system. There's many different tools that you can use to manage having multiple different versions of Python available on your system. Again, we're not going to get into that today. We're going to stay focused on UV. So let's take a look at, well, first let's clean up anything we left behind here. So I'm going to delete virtual env, delete all this stuff. Okay, back to the basics here. Okay. All right. So let's change this. Let's say we've got an older application that requires Python version 3.10 for whatever reason. And I'm going to just run again, I've deleted all of our environment and everything. I'm going to just run UV run PyTest again. And I get an error that says that is incompatible with the project's Python requirement. So our Python version file, 3.10, and the requirement of our project in our pyproject.toml are incompatible, and UV is going to flag that for us, which is great. So I'm going to adjust that just for this. We'll say we have this legacy version. I do that. And if you saw that, it kind of flashed pretty quick. So I just typed, again, this is in this project. We didn't have a virtual env yet, but when I ran my tests, it said using CPython 3.10.20, creating a virtual env, installing the packages, and then running the tests. So, if I run Python, UV run Python version 3.10. And if I just use my system Python, I guess that is from my Py project. So my system already identified that. So the nice thing is that UV not only manages dependencies in terms of my requests and my dev dependencies, but it also manages dependencies in terms of my Python dependency. So if I change this back to 3.13, and let's go ahead and delete. No, let's just leave it. I actually don't know what's going to happen if I leave my virtual env here that was created with Python 3.10. We'll see what happens. UV run PyTest. So it did switch. So you can see on my prompt there, it's got 3.13, Python version 3.13. And if we scroll up, we should see what UV did. Yeah, using CPython 3.13, removed virtual env, created virtual env. So it automatically recognized that I had updated my project configuration, and it changed the Python version. So super easy. Didn't have to go to any other tools. Just had to update the configuration in my project. One last thing I want to talk about. Well, I guess a couple things. One is how fast it is. It is really, really fast. The fact that, this project is very small, so it's not a great example, but you'll notice that it creates the environment so quickly that you almost don't even notice it, and it just does it all on the fly. There is a little bit of a trick. There's a local cache, which I'm going to delete now. So basically, if I've got 10 different Python projects on my machine, they all require the same version of requests. UV isn't going to go out to the web, download that package 10 times for each project. It's going to go out to the web, download it one time, put it in a cache, and then all my 10 projects that need that same version can just grab it from my local cache, which makes it really fast. So I just deleted the cache, and did I delete? Yes, I deleted my virtual env. So this will be, again, from scratch with no cache, UV run PyTest. So it took a little bit longer, and if we scroll up, we can see that it did. Oh no, it got rid of the output. You could kind of see there was a little bit of a flicker as it was downloading the packages, but still happened really quick, which is super nice. The other thing that is a little bit different is the uv.lock. So this is something that is supported in some way by many other tools. So like pip, you can do a pip freeze to create essentially a locked down version of every single dependency, both your direct dependencies and your transitive dependencies. So let's talk about that for just one quick second. If I delete my virtual env again, and I just do UV sync. So this is just going to grab my, basically just build my virtual env. So You don't need to manually do this step if you're just going to run your tests, run your application. UV can automatically do that for you. I'm just going to run sync. That's basically going to build my environment. So you can see that it's listing more things than what I'm depending on, right? It's got request responses, it's got PyTest, but it has all these other packages as well. So those are transitive dependencies. So those are basically the dependencies of my dependencies. And so what the lock file does is when I build my environment, when I run that sync command, it is essentially going to say, okay, your project needs these versions of these dependencies. Those versions of those dependencies depend on these versions of these dependencies. And it's going to keep going until there's no more dependencies to figure out. But it's going to do all that calculation to get the latest version that fits the criteria. So if you have specific minimum versions or maximum versions or exact versions that you need, it's going to do the calculations to come up with the correct versions of everything. And the reason that that lock file is important is that your application, when you build it and you test it, you have a specific set of those, and that calculation every time it runs may change, right? So like if I have this pigments dependency as a transitive dependency, I don't specify the version of that. One of my dependencies dependencies specifies that version, and I have no control over how that dependency is defined. It may be defined as a minimum version. So that may be something that PyTest says, I need pigments at least version 2. And so what I'm getting is version 2.20. If a version 2.21 is released, then, and I rebuild my environment, it will pull that in. But if I don't want to rebuild my environment, if I want to make sure that what's on my machine right now in this moment is the exact code that gets deployed, then I can use that lock file, and that lock file is going to have these exact versions locked in, and those are the only versions that are going to be installed. Managing those transitive dependencies can be very important for consistency, and also to kind of protect yourself against potential like supply chain attacks, where if a malicious version of one of these dependencies gets published and you don't want to pull that in, you only want to pull in the versions that you've already vetted, that you've already tested, that you know are working in your application and are secure, then you can use that lock file, and you can use, and you might have seen, I think my autocomplete, yeah, you can do locked. And so this will ignore basically will only consider the things that are in the uv.lock file. There is a newer standard that is called pylock.toml, I believe. And I believe pip version 26 supports that. And I think that is kind of the new standard. UV does not use that new standard. Maybe someday they will support it, but that seems like the kind of the Python community going forward, the standard of the format of the lock file. So hopefully at some point all these different ways to lock things will kind of converge, and there'll be one more universal way to support that. Well, I think that pretty much covers kind of a high-level introduction to UV. There's a lot more to it. There's a lot more that you can do. So this is just kind of scratching the surface. But it is a really great tool. I really enjoyed using it. I enjoy how fast it is. I enjoy how it kind of automatically does a lot of things that I previously would have had to have manually done. The Astral tools, which there are a few more that maybe we'll talk about at some point in the future, but they all seem very solid. I've really enjoyed using them, and hopefully you've learned something today. Hopefully you're interested in trying this out. This has been Matt Morrison with Technically Speaking at Source Allies. Do you have a topic that you want to see covered? Comment it down below. Check out sourceallies.com to learn more about us. Thanks for watching, and we'll see you next time.